Hi everyone, welcome back. In this video we're going to see how we can define functions and then use them. And let's start with the definition. So definition of a function formally in the source code is the signature of the function and then its body. And signature is basically the part which says what the function does, and the body is which has the code which basically says how it does it, how it does what it does. So, and again, if we split it, define it more formally, the signature is optionally some keyword. So this, the definition in different languages might look very, very differently. So it will be hard to give just a single pattern saying, okay, this is how it looks in all the languages, but I'll try to describe it in a way that you'll at least recognize in most of the languages that this is a function definition. So again, the signature will either have some optional keyword which determines in the specific language that this is a function definition. In some languages there won't be any. And then it has the name of the function. And then there is a list of parameters, basically the input parameters, what kind of values or what kind of input this function accepts. And finally there is the return type, basically the type of the object or the value this function will return. And most of these, not most, like the name is the only required part here. So a function can might not have any input parameters, and also it might not return any values. And in some languages, even if the function, so for instance, let's say JavaScript, even if your function returns something, you don't write anything in the definition of your function in the signature about that. So it's a dynamically typed language. You can just assign the result of the function call to a variable. It will work. So again, optionally some special keyword, and then optionally return type, and then the name of the function, and optional list of parameters. So for list of parameters, it's basically either empty again, which means it was optional, or so 0 or more parameters, which is each parameter is a name and the type of that parameter, the data type. But again, in dynamically typed languages, we can have just the names of the input parameters without the types listed. And in some cases, some parameters might have default values, which is, we'll come back to that. So basically, in short, it's if you're calling a function and in most cases you pass a specific particular value for this parameter, you can set that value as a default, and whenever you want to use another value, you'll just explicitly state that you want to pass this value, not the default. Okay, so that's about the signature. And then after signature, there is the function body, which is included in some kind of a block. So it's either in curly braces, or in some languages, if the special keyword denoting the beginning of definition of function has a pairing, has a basically closing keyword. So for instance, there might be sub and sub in some language, or function and then begin end. But yeah, in most mainstream languages, there will be just after the signature line, there will be a curly brace, opening brace, and then after the body is finished, there will be the closing brace. So function body is just a sequence of statements. So what the function needs to do, which uses the input parameters, and then at the end, if it returns something, there will be a special keyword return and the result, or whatever value it should return. So that's the body of the function. And the return type, or the object the function returns, can be of any data type that we can think of. It can be built-in, it can be custom, user-defined. So as I said, different languages have different names. Some don't have, or keywords. There is this function, there is def, there is sub, there is proc or proc, which stands for procedure, short for procedure. And there are many other keywords. So when you see any of these, it means basically there is a definition of function coming after that. So that's about definition. Here I just listed two definitions in different languages for the same function, which is called max, and it returns basically the greater of the two input values. And note that in one is a statically typed language, so we specified the type of the return type, and then the types of the input parameters, all being integers. And then the code is just simple one-liner, which says if a is greater than b, then return a, otherwise return b. So the next example does the same exact thing, but it's for dynamically typed language, let's say JavaScript. And it does the same thing. The code is the same. There are some nuances. There are some real differences in these two. So for instance, one thing is for integers, we know for sure the greater than operator is supported, so it will work. For the dynamically typed, since we don't know the types of A and B at compile time, when we are writing the code, we are not sure, we don't know if the greater than operator is supported for this type. So at runtime, when we invoke this function and provide values of some type which doesn't support this greater than operator, this function might fail. So you might get some exception, or your process might terminate. Again, yeah, there are some differences, but in general, these functions are doing the same thing. They will definitely work for integers. If you pass integers, both functions will do the same thing. So this is about definition. So another interesting thing is the declaration of the function. So in some languages, so let's start actually what's a declaration. So declaration is basically the saying to the compiler or the interpreter that I have this function, right? It's either I will define it later, or it will come from somewhere else, not from this file, but you're just letting the compiler know that there is this function, and you don't specify the body, just the signature. So if you provide the signature, that's basically a declaration, and you make it a statement. So if for instance we use semicolon in that language, then the declaration is just the signature and then semicolon at the end. So that basically lets your environment, runtime environment, or the compiler, depending if it's statically typed or dynamically typed language, know that you will have this function, or you can use this function. So some languages won't let you use a function if you didn't declare it previously. And previously means before you're reaching the source code, so the line number of the declaration should be smaller or less than the line number of the where you are using that function. So there are some other cases where we need the declaration, for instance when we define interfaces or abstract classes, but we don't know about those yet, so I'll just skip. Know that the declaration of a function, it's similar to basically declaring a variable when we are saying, okay, create this variable, but we are not going to assign anything to it. Actually, no, it's not very similar to it, but anyway, yeah. So the declaration is the signature of the function and wrapped in some, or completed by some syntax which makes it a statement. So knowing that we can now define a function, we need to know how to use it, and that's the easiest part. We basically, to be able to use a function, or it's called, the term is invoke or call a function, So when we want to use or call this function that we defined previously, we just write the function's name, and then in most languages this syntax is supported, so function name, then opening parentheses, and then the values for input parameters, and then close the parentheses, and done, and semicolon, or depending on if you need a semicolon to make a statement. But that's basically a function call. So the function call results in the control flow, or basically the execution of the program, go and start executing the statements in the definition or in the body of the function. And then if the function is defined so that it returns some result, then you can assign this function call to a variable. So for instance, for that max function we defined above, we can say, if we have, let's say, two variables a and b, from somewhere user input, or we just had it previously, and then we can say int creator equals max ab, which means it will call the function, it will create a new variable creator, then call the function, calculate basically whatever result the function returns, and then assign that result to the variable creator. There is a special case. There is a type name void, which really is not a type name. Void means basically the function doesn't return anything. So if in a statically typed language you are defining a function and saying in signature, instead of return type you're writing, or not instead of for return type you're writing void, it means this function doesn't return anything. It just does some things, maybe like think of anything that basically doesn't return. So it can be logging a message, it can be making some sound, whatever. Yeah, it can be just shutting down the computer, anything basically, but it doesn't return a result of any type. So then we say, for instance, if it's a log, we can say void log, and then the only parameter is a string message, right? The message is the name of the parameter, string is the type. So apparently for void functions we cannot assign the result of the function call to a variable because it doesn't return a result. Yeah, I think so. We know now how to define a function, and again, this is just the simplest ways of doing things. There are many other ways, and depending on languages there might be more, but this is the simplest form and this is the most common form of defining functions. And now we know how we can invoke the functions we defined. So this gives us the ability now to basically wrap any piece of logic of our program in a function and call it as many times as we want from wherever we want. So for instance, let's consider the same example from that what was it called, square root problem. When we needed the absolute value, basically we can now define a function, call it absolute, and it accepts only one parameter. Let's make it double. So double x, and then since the input is double, the return type also will be double. So the signature will be double absolute, and in parentheses double x. And then the result is just return, if x is greater than 0, return x, otherwise return minus x. So yeah, in some dynamically typed language, again I picked JavaScript for this example, it would be function absolute x, and then the body is the same. So yeah, this pretty much covers the basic way of defining a function and declaring a function and then invoking a function. So one important distinction in these terms is when you define a function, the input parameters, the objects you pass as inputs, are called parameters, right? In the definition, those are parameters. But when you call or invoke the function, the objects or the values you pass to assign to those parameters are called arguments. So these terms are usually used interchangeably, but the right definition is arguments are the ones that are used at the time of the call, and parameters are the ones that are listed in the definition. So this is like a small distinction, but important. Yeah, I think that's it. So let's do some simple exercise in the next video. Try to solve some problem in which we'll need to have some pieces of logic separated into their own functions, so that we understand how they are useful, and then we can also map this knowledge of the last video, the benefits these functions provide, and understand basically how it works. So let's do one exercise in the next video, and then we'll get to more details about functions, more edge cases, and what other features functions provide, what else we can do with them after that. All right, thank you very much. See you in the next one.